So, while you guys are doing that, we are using RSLogix 5000. If you move the mouse on your computer, you will see that I already have the software opened up for you because I want to make sure we weren't going to have any issues with that. Not saying it's a perfect solution, but it will, we should be good right now at least. Alright. This software is license-based. It's from our local servers, wherever they are, so that can cause some problems, but right now it's working out with just fine. Alright. On my screen / view screen, you guys should see the software. Alright. At the very top, you know what, let's change notes. So we're going to go ahead and do a file new. Alright. And you will see a little window pop up. If your computer doesn't freeze. There we go. Alright, and under type. Alright, if you go ahead and just click that little drop down, you'll see there is a boatload of options. Alright. Looking at the PLCs that we have in front of us. Alright, if we look at our controller unit. I'll bring mine down a little bit. Alright, remember your controller is this far leftmost box. Alright. If we look on it right now, we see right where my finger's pointing, you should see it says L32E. It does not say anywhere what number otherwise than that. Alright, we are using 1769s. It does actually say other places. It's just written on the sides of the card. We'll pull one off these later in a few minutes, but we'll come back to that moment. But anyway, so we're going to use the 1769-L32E. Alright, not the L35ZR, not the L32C. We're doing the L32E. Alright, so you can go ahead and click on that. It's already probably defaulted to that one because that's all we ever use in this room, so it's probably already there. And then you have to go ahead and give it a name. Alright, I don't care what you name it. If you just want to call it test or, intro, whatever. Just give it a name. Go ahead and you can hit OK after that. I named mine test and I already had a test file that's yelling at me, but you guys probably will be fine. Alright, and you go ahead and hit OK, and the software is going to take a minute to bring up everything. Looks like your computers actually might be a little bit faster than mine. Just kind of sad. Alright, compared to Siemens software, I think this software actually works a little bit better on smaller screens. Alright, I don't think there's as much, not junk around, but, not as many windows that are, like, floating all around your screen. If you kind of notice, you've got a project tree on the left-hand side, and that's really it, and then your bar across the top. Where in the Siemens world, we had a bar across the top, we had a bar across the left, we had a bar across the right, we had a bar across the bottom, it just was like, when is this going to end? Alright, so, we had a lot going on there, and mine finally caught up. So, on the left, we have our controller organizer or project tree. Alright, you guys should have watched those videos and whatnot, so you should already be a little bit familiar with what's going on here. We have our controller tags at the top. Alright, if we expand main program under test, you'll see we also have program tags. Alright, controller tags are accessible from anything on the PLC. Program tags are only accessible from that specific group of programs. Alright, so in this case, anything in this main program, it can access those main program tags. If you would do a new program, if you would right-click on main task and you'd pick a new program, I'm just going to call it prog2, you'll notice that one also has its own set of program tags. Alright, so you do need to be a little bit careful here where you are creating your tags. Alright, for the most part, you guys will have one main program, and then we'll have our controller tags. You really only have two different tag locations, and it's not really an issue where you put them. I mean, maybe going, why the hell did I have this? Alright, and the real reason I have this is for memory use. Alright, controller tags have to be stored basically in memory the entire time the program is running. Alright, where program tags, in theory, they can be deleted from memory when that program is not actively running. So you're able to conserve some memory. If you had 12 programs, each having 100 megabytes of tags, or things like that, which would be absolutely nuts, but let's just use my logic here. That would be 1.2 gigabytes of program tags if you put them all in the controller tag section. Right? If, however, you put them all, the tags that you needed in the program tags, but you still had some overlap that, multiple programs needed access to the system timer or whatever, you'd only have 200 megabytes of tags being actively stored in the memory at any given point in time, because only one program is being run at any point in time. So it allows you to do some memory management. For our purposes, our art class, we don't really have that big of an issue. We're not storing, you guys aren't writing 1,000-line programs in here, so it's not really a problem. Very few stories have I heard of people running out of memory on their PLCs, to the point where they're having to go back and, try to streamline things. All right. Not saying it isn't possible, because it does happen, but I've only heard a few stories of that actually happening. So just kind of keep that in the back of your mind. Anyway, controller tags and program tags. If you want to create a tag of either sort, it's Control W. All right. I did look at your guys' quizzes. Someone said Control T was the answer, which to me makes sense. All right. Is Control W. I don't know if that's like a right or what the W stands for in this aspect, but W is the shortcut key. And I find that a lot easier than having to go right-click on program tags or controller tags to do it. All right. You will need to fill in a few pieces of information, name being the most important. I'm just going to go with start. Type is the second most important. Now, for the most part in this class, you will be either using base or alias. All right. We will be getting to a point where we are doing some networking, where you're trying to communicate with the PLC next to you. And in that case, the produced and consumed tags become very important. But we're not there yet, so we'll talk more about those tags later. So, base or alias. If you do choose alias, giving it what it's an alias for is very important. All right, so which input on our PLC is actually being used. All right, and we'll come back to that one in a minute. We can't make an alias tag right now because we have no inputs on our PLC. Data type is important. All right, that will change automatically for your aliases depending on what you're aliasing. If you're using a base, then you have to pick which data type you're using. Most of the time, again, you'll probably want a Boolean data type if you're just trying to do a ones and a zeros. All right. And then the scope. This is where you would pick whether it's the whole program or a specific one. All right, so is this a controller tag, which would be the name of your program, in my case, test, or is this a specific program tag, which would be main program or prog2? All right. I do highly suggest that you guys try to put your tags in your specific program one when possible. It makes sorting things later and I think finding tags later a little bit easier, but that's a personal preference there for me. Does it really matter? No, I'm not going to take points off if you put all your tags in the controller tag section because you forgot to change the field. That is most likely what's going to happen, is you're going to forget to change this field. All right. Luckily, it does default to, I think, the controller, so it's not really a problem. So, I'll go ahead and hit OK. If I go ahead in my controller tags, or did I make that program tag? One. There we go. Now I can see that I have a start type. I noticed that there's actually, I wish I could zoom in nicely, but there are 31 instances of start. All right. And that's because it was a dint data type. So I have start.0, start.1, .2, .3, all the way to 31. All right, so there are 31 different bits that I can change from zeros to ones. Normally, we're going to use that for storing a number, but you can use this for storing specific bits of information if you wanted to. All right, you guys talked about how to do stages last, with the Siemens, and how you did like stage 0, stage 1, stage 2, stage 3, yada yada yada. Well, you could create a dint data type for that and just do stage.0, stage.1, stage.2, instead of having to go and make different data types for every stage. So it's kind of a quick little shortcut to be like, okay, I need a whole bunch of stages, give me a dint or an int or whatever, and bam, you've got a whole bunch of stages all ready to go for you. So that's how I like to do it anyway. As we move down, all right, we're going to skip motion groups for now. We're going to skip add-ons and data types and friends. However, we're going to come down here to I/O configuration. All right. Now, because this is a modular PLC, all right, the PLC has no flippin' clue what is attached to it right now. All right. As far as it's concerned, all you have in your program is the CPU itself. All right. Now, if we look at our CPU for a second, all right, you notice that we do have a nice Ethernet port. All right, that's nice. It makes our lives a little easier. We don't have to add an Ethernet card. We even have actually a serial port. I'm assuming this is going to be an RS-232 based port, which again is nice. All right, we have a little compact flash upgrade. All right, basically it's an SD card, but it's a big square one that physically is a box. It's not a little, I don't know, flunkiness of the SD card. And then we also do have keys. Alright? Now, all of the keys are exactly the same. There's really nothing special about these keys. All they do is keep the average Joe Schmo from turning the key on the PLC. Could you probably do it with a paperclip? I would assume so. Alright? I mean, if you look at the key, all it has is a little one bump up, one bump down type of thing. So, probably a pick resistance of this is pretty low, but we don't need to test that. You all have keys. But anyway, there is a key, and if we actually look very closely at this, you'll notice that there's 3 different modes. We have a run mode, we have an REM mode, and we have a PROG mode. What do you think run mode is? Normal run, runs the code. Alright, what's REM mode? Alright, we'll come back to that one, guys. What's prog? Nope. Nope. What's prog? Program. Alright, so if we're going to program it, we have to be connected to a PLC. Or we have to, no, not to a PLC, to a computer of some sort. Alright, if it's running, we don't need any connection. Alright, REM. Alright, if you are stranded on an island somewhere, you are on a blank island. Starts with an R. Remote. Alright, so REM would be remote. Alright, so that actually basically allows us to control the PLC modes and things like that from the computer itself. So if you actually, again, notice at the top here, we have an offline mode. We can go online. There we have program, run, test. So REM mode is what I would suggest that you guys just leave this in and never change it. All right. If you put it in run mode, and if you turn the key, and then you're like, oh, let me change something from the computer, you have to turn the key back to either REM or program before you can do something. So if you just leave it in REM mode, you can just do everything from the computer. It makes your life easier, and you won't forget that. You don't have to constantly be turning the key back and forth. All right. Again, for industrial world, having the capability to get out of being able to be configured or altered from the network is a security thing. All right. You have an application where you don't want people to be able to hack into your PLC. If you put it in run mode, they can't stop it. They can't start it. They can't upload new code. So it's kind of a security protocol there, not more than anything else. Again, it's secured by a stupid key, but it's still a little bit of a security. Also, don't lose these keys. They can plug in. You know, you can remove them in any state. It's not like the key gets locked in there as it's turned, so just don't lose the keys on me. Alright? But anyway, so that is all we have right now according to our program. So we have to add in our different cards. Now, do you remember what this is? Power supply. Alright. So, as far as it's concerned, that doesn't exist. Alright, we need to have a power supply of some sort, but it doesn't exist in the PLC. We don't have to tell it you have this power supply. We just have a power supply. Alright. Now, the PLC, the main CPU, that is card number 0. Alright. So, if the power supply doesn't exist, does that get a card number? No. Alright. So, next we have a device net input. Alright, so this allows us to connect remote I/O and things like that. Alright. At this point, this is kind of being a bit of an older protocol that you're still going to see used out there, but I think Ethernet is replacing those. So instead of having to go device net and set up everything, configure it all to be on the device net, and this, that, and the other thing, most of the time we're probably just communicating over Ethernet, over a Ethernet I/O, I believe is what it is, which is an industrial Ethernet standard, which is meant for more real-time communication. Your standard Ethernet has some lag to it, maybe 20, 30, 40, 50 milliseconds, up to, depending on network traffic and whatnot. And that may be the point of you missing turning your pump off and overflowing a tank. So that's the reason they didn't like Ethernet, but with the higher speed Ethernets and things like that, and the newer standards that have come out, Ethernet is starting to become a more real-time communication down to a few milliseconds of lag time. So completely capable of not missing those critical transitions and things like that. Device net was, I said, the kind of the standard before that, so it was nice. You will see that we've got some numbers displaying on this screen. As if you turn it off and you turn it back on, you'll see those numbers will change as it boots. That's kind of going to go through like a self-check here in a minute once the PLC decides to start doing everything. All right. So anyway, and then a little plug here that has all the wires we need. So there's all 88, 4 to 92. All right, so that's there. So then we have 3 actually important cards I'm going to call them for this semester. We're probably not going to ever touch device net. All right. So if you guys look at your 3 cards, what type of cards do we have on your PLCs? Yeah, okay, someone said sync source, source, and analog. Alright, are they inputs or outputs? What did you guys say? Yes, the blue one is inputs. So that card right there is inputs. And if we read right at the top, it says DC input. Alright. The next one, DC output. And the last one is in and out. Alright. So we have how many inputs? Try again. 16. You gotta count the 0. Yeah, I was waiting for that answer. Alright. We have 16 inputs. These can be source or sync for our purposes. These are set up as syncs. So that means when they see 24 volts, they call that a true. All right. If you actually pull the little flap open, you can see all the wires in there. All right. We have 16 DC outputs. These are sourcing outputs. We don't have an option there. And then we have, let's see, 4 analog input and 2 analog output. All right. And again, if you would open this up, anyway. You can see 0, 1, 2, 3 for our analog in, and 0 and 1 for our analog out. All right. So we have both analog input, we have analog in, analog out, DC in, DC out. All right. So overall, all good there. However, we do not, as I said, have this in our program at all. As far as it's concerned, all we have is this one specific card. All right. So to add them, you're going to right-click on Compact Bus Local at the bottom of that project tree on the left. And you're going to go ahead and say new module. So, which module do you guys want to add first? We're going to put all 5 in for good measure today, or 4 in today, not 5. We can put the device net in first, that's fine. All right, what is device net? Under analog, communication, digital, other, or specialty? It would be a communication, excellent. All right, and if you notice, there are 2 of them. Ooh. 1769-SDNA/A or /B. What do you guys think? You think A. Well, we can add the A one for now, and we'll prove that right or wrong in a little bit. So you guys can go ahead and hit OK. And then just go ahead and hit OK again for that one. And then OK again. Now you will notice under that Compact Bus Local, it says square bracket 1 1769-SDNA/A. All right. What do you think square bracket 1 square bracket means? Okay. So what does that tell us? It can, yes. All right. More importantly, what does that tell us? There's something for it. The slot that it's in. All right. So that's saying that this is slot 1. That device net, all right? So we have the CPU at 0, power supply doesn't count, device net is 1, all right? Now, just to screw with you guys, we're going to go ahead and put the output in this time. So go ahead, right-click, new module. All right, we're going to go to the digital, and oh my god, there are a lot of options there. All right, the information you need is on your PLC and somewhat easily viewable without you breaking or taking anything too far apart. Can you find the information about which specific output module we are using? All right, they found it. Anyone else? Did you guys find it? Which one is it? Excellent. All right, so if you actually open the little door on your output card, you'll see that it says at the very bottom 1769 OB16. Now, you have to be careful about that because those little cards are removable. And it also means that somebody could put the card in the wrong freaking slot. So, just be aware of that if you're ever like working with something and be like, oh, it's this module. It might not actually be that module. But in this case, they are correct. So these are the 1769 OB16. So go ahead and select that, hit OK. Now, I told you that I'm screwing with you guys. All right, so device net went to slot 1. How do we tell us that we're in slot? What slot are we in? We're not in slot 2. 3. All right, as Jeff said, little drop-down thing. There's a drop-down that says slot on the right side of that window that popped up. You can go ahead and click that and just tell it that we're in 3. You will notice that 1 is not an option. Why do you think 1 is not an option? We've already used it. All right. So in this case, we can go ahead and select 3 and go ahead and hit OK. You can go ahead and repeat that process for the input, which is the IQ16. Throw that in slot 2. And then you can go ahead and also create your analog. And that one is the 1F4XOF2. Alright, so we've now told it that we have all of our different modules installed. Alright, so let's go ahead and actually create a tag that is an alias for something. So what's our shortcut key? Control W. If it helps if I'm clicked. Alright, I'm going to go ahead and call this my start button. Change my base to an alias. And now when you click that little drop-down arrow next to in that alias column, all right, you'll see a whole boatload of options. All right, so you'll notice that they all start with local. All right, and what that tells us is they are local on our module. All right, these are not remote I/O. All right, when I'm saying remote I/O, I'm saying something like this. That would be a remote I/O module. Actually, I can't think that one up to required. So this one, that is a remote I/O module. So this one has 16 more inputs, 16 more. So, kind of handy. But since it says local, it is actually on the rack that the PLC is on. Now, just because it says remote doesn't mean it's 100 yards away from us. It could still be in that exact same control cabinet. You just may not have had any more input cards for your specific PLC, or you've used up as many slots as your PLC can handle. If you need more I/O, then you have to go remote. So just because it says remote doesn't mean it's super far away. It could just be that, we need more I/O than we could handle directly on the back plane of the PLC. So we went to a remote option. So just something to be aware of. Anyway. Now, if you notice, we have local 1I, local 10, local 2I, local 3C, local 3I, local 30. It's like, what the hell's going on here? All right. So when we create these modules, it goes, okay, this is this. A lot of stuff going on there. Now, our input is which module? 2. All right. Device net is 1. Input is 2. So if you go ahead and open up local 2I, you will now notice that there are 2 more options. There is fault and data. We're just going to stick with data. We're not going to get into faults in this class. So if you go ahead and click on data, you'll notice there's another little drop-down option. And this is showing you all the numbers on that specific card. So 0 through 15. All right. So now you can just kind of click one. We're just going to go with 0 because 0 makes the most sense to me. And you can go ahead and hit OK. And then let's go ahead and do that same process, but do a stop button this time. I'll give you guys a second to go ahead and do that. All right. Just as a reminder, this is local 2I, data, and then you pick the bit number or which specific terminal that you want. Now, once you get to the point of adding the stop button, if you stop there for a second before you actually click the terminal, what do you notice is a little different this time? Yeah, 0 is kind of grayed out, which basically just tells you, hey, you already have an alias for this. All right. You could use it again. The software I don't think is even going to yell at you like Siemens does. But it's just kind of like giving you like a little warning, like, hey, this one you already have a tag for, just in case you care. All right. So in this case, we can just go ahead and select 1. Now, one of the reasons that I like putting my alias, my tags in the program tags instead of the controller tags is it keeps me away from having all of these different, all of my different card stuff when I go look at my tags. It's just one less thing that I have to focus on. It makes my life a little bit easier. That's why I like to put them in the program tags. If you notice, I screwed up, and I put them both in my start controller tags. So, again, it doesn't really matter, but it's just nice to be able to go, okay, I just have to look at my program tags to see my aliases I've created. So, a little bit of give and take. All right.
So would you need for different or just for this program does?
Yes. So I would create, ideally, again, for anything we're doing in here, everything is going to be simple enough that we're going to only have one main program. All right. You may have some subroutines or functions in that program, but we're only going to really have one main program. All right. So that's not really a huge problem in the long run. So I like to create all my tags in the program. All right. And again, each tag represents one input or output, basically. All right. But yeah, no, if you had, one PLC that was doing like an assembly line over here and a feeding station over here, you'd probably have multiple programs and you'd want to have their tags be completely separate because they're never going to try to crosstalk. All right. It's if program A needs access to program B's information, that's when it needs to be a controller tag because anybody can access them. All right. So like again, if you had two assembly lines, they don't truly need to talk back and forth. And maybe you have one master stop button. Well, that one would be a controller tag because both of them would be checking that stop button, saying, "Oh, should we?" Or we know just one big kill switch that would kill everything in the factory type of thing. I don't think those normally exist. Normally, it's like specific to assembly line or even a station. But there might be one big one that would kill the entire factory. I have one for this room. I've never pressed the button. I'm over curious. I feel like it's going to just turn all your computers and things like that off. If you have the priorities and things set up properly, yes, it could. Yep. There are, if we go ahead and right-click on the main program and go to properties, under configuration, there's a fault option, there's a monitor option, which allows us to set the max microseconds that a program will run for. I believe yes. You also have scheduled programs versus unscheduled programs, so there's a whole lot of. Yeah, you could say at 2 o'clock every day run this program type of thing. So I think so, but I'm not positive on the priority of one over another one. But again, traditionally we're running our program so fast, it's not it's a few milliseconds. It's like, oh, if the program takes 10 milliseconds to run, that's a long program. All right. So our task is actually, programs are within a task in this. So if you look, you have your tasks, we have our main task, and we have our programs inside of that. So you can do a new, we can do a new task. Hi. There we go. So now we have a new task, and this one actually looks like it is time-based. So here we have our scheduled versus unscheduled, or monitoring it. Here's periodic. We can do a specific event. So this is an instruction-only event versus a motion group versus an access watch. So again, lots of things going on there. And periodic would be a certain time. I think there's a way to set that up. So there's tasks, then programs are within that tasks, and then functions or routines are within those programs. Again, it's a hierarchical tree. It just takes a little bit to get used to. All right, so how do we write a program? All right, we guys have written them in Siemens. Let's try to write them in Allen Bradley. So if we go ahead and click on that main routine, now this I think I can blow up for you guys. So at the top of your screen, all right, there's two really important screen subsections here. We have this one that I just pulled off, which is your online one. This is where we have what mode we're in, your PLC's in run, okay, we're having I/O issues, stuff like that. If we're online or offline, if we have stuff forced, if we have edits that are being, are in the works. And then your other important one is this screen, as far as I'm concerned. And this is your language element, as they call it. So you can see you have a whole bunch of different tabs, and I do suggest that you guys make that as wide as you can if it's not already that super wide. Because having to scroll through this is really annoying. because there are two different scrolls. If you look, there are scroll arrows right next to your elements, and then there's scroll arrows right down here by the tabs. So if you want to scroll the tabs, and you probably like me, you're like, oh, let me just click this arrow to scroll over. It's not that arrow, it's the one over here by the tabs. Which I just find really annoying. Alright. But anyway, so I would make that the whole width of your screen just to save you from having to scroll those tabs as much. So inside favorites, we have a new rung. Now, Siemens, it doesn't care if you have an empty rung. Alright? Allen Bradley does. Alright, if you notice there's an E, I think this E is actually for edit, but it might be for error as well. So, like, if I were to try to download this right now, it'd be like, nope, you can't do it. Alright, so we have to have something on every rung. Otherwise, delete them. No, it's going to be the first mistakes you guys are going to make. You're like, why is this not happening? And because of the freaking rungs. But anyway, so we have new rungs. Then we have our branch command. Alright, so those are those little OR statements, basically. We have add another branch to a branch. We have our make, our break, our output, our unlatch, and our latch. Those are the default favorites. Alright. If you scroll on along those bottom tabs, if you go to the bit one, you'll notice that we also have our one shot rising, our one shot falling, or just one shot. Alright. If you go, we have our timer tab, then we have a counter tab. Our timer and counters are part of the same one, sorry. There you can see that reset instruction for timers and counters. That res. Alright. So that's where that reset is if you guys need it, which and like again, unlike Siemens where it includes like in a counter a reset like line right part of it, Allen Bradley doesn't. It's just its own little whole rung is to itself as a reset command. Which I actually overall think I like this system better. Because then when you want to put multiple things on it, you don't have to like put one and drag the line to it, and I just find that to be really annoying. So, I kind of like having it as its own separate rung, but that's my own personal statement. Just as a reminder to you guys, again, Allen Bradley World, we have EN and DN at the back of this. So if you notice, EN is what is on the line. DN is what's below the line. Alright? So, how in Siemens you'd be like, when this timer's done counting, and you just put like another output right after the timer, so that output would turn on once that timer's done counting. We can't do that in Allen Bradley World. You have to give it its own rung with its own, when the timer is done, .dn output whatever. All right, so you have to separate things a little bit. This is how I learned. So this is what I'm used to, which is why when you guys did it in Siemens and you just threw it right there at the end, I'm like, I don't really like that. I mean, it works. I don't like it, and it's because I learned in Allen Bradley World, not in Siemens World. Okay. Again, it's annoying, but it's yeah. Everyone does it its own way. All right. Anyway, also in Allen Bradley World, you have to create your timer tags yourself. You know how in Siemens you'd put it in and be like, hey, we need to create a data block. What's the name of your timer? And it just ask you for it. Allen Bradley World, you have to create it yourself. So you would have to say Control W. I'm just going to call this my timer. And then under data type, there is a timer data type. Alright, so it's overall very simple to create. And again, if I go to my controller tags, that one put it in my program tags. You can see, here's all my timer. I have my timer I have my preset, my timer accumulated, my timer enabled, my timer timing. Yes, you get timer timing! That's very exciting to me. I hate how Siemens is like, it's there, it's timer running, but you can't use it. Like, just giving you the middle finger, in my opinion. Yep, you don't have to do if the timer's enabled and not done. You can just do timer timing and move on. Really nice, in my opinion. So yeah, that whole creating this is really nice. You also notice if you look very closely at this, which you guys probably can't see very well, but the enable, the TT, and the DN, those are all booleans, but the pre and the accumulated are dints. So it actually has different data types for, all inside that one group. And again, that was done in the Siemens World too. I just don't think I ever pointed out to you guys how we had the different data types there. But anyway, so now that I have a timer, I could double click on this and I can select it. Boom, automatically fills everything in for me. So again, kind of nice. Notice my E's went away, my R's, because it's like, oh, there's a timer on this run. I'm happy now. All right. But I just put just this on there. I still have errors, even if I give this a name. So I call this my start. Still have errors because there's no output. It's like I don't. What's the point of this run? So you do need to give it some sort of output and name that. And yep, still doesn't like that because I have used an input as an output. So something to be aware of. You can create tags here, so I'm just going to call this output. And again, notice I still have E's because output doesn't exist right now. So you can right click on that tag and say new output, and it will automatically put the name in the tag instruction for you. So kind of nice. Then you could come and create the alias if you wanted to, or you could hit OK. It even knows the data type because this is a bit data type. You know, that the tag that it is, the output is a Boolean option. So automatically goes, well, if this tag is in that instruction type, it has to be this data type. So kind of nice in that aspect. I don't know why. Oh, really? I don't know why we're getting errors at this point. Oh, because it's a dint. So because this is a dint, I remember I had told you guys how we had 32 different options for it. I have to give this a specific bit of that dint. So you do that by typing period and then a number. So in this case, it's between 0 and 31. So I could say my start bit there is on .16. And that got my error to go away. So now everything's happy. That's just different options within that memory. Nope. Yeah, no, because how I did this, no. It's just that whole thing. It's just the memory bit. It's not an alias for anything. Again, I use it for my stages. So this would be stage 16. Instead of having to create stage 1, stage 2, stage 3, I just go, give me a dint or an int of this, and Yes, but you can also use them as inputs, remember? So, yeah, no, my reset, my set would be somewhere else. But yeah, so that .16, that's, you just have to be careful about it. We couldn't do that in Siemens World. We could not reference a specific bit of a tag. All right. Now, what we don't have in Allen Bradley World anymore, all right, is clock bits. You know how when you want to make something flash, you just turn the clock bits on. You said, clock 5 hertz, 10 hertz, or whatever, and it flashed for you. We don't have that as an option. All right, doesn't exist. You have to do 2 timers to create a loop.
Sorry.
Yep.
So the same start?
Nope, that'd be 2 different. It's 2 different addresses. So one's referencing address 15 of bit 15, and one's referencing bit 16. So it's actually no, because these are just bases. They're not aliases, so they don't represent anything. So you know how in Siemens World you had to select memory, you do M whatever. We don't have to tell us it's an M. By selecting base, that's basically telling it it's an M. And we don't have to tell it which memory bit to use, which I freaking love. Because you know how you guys have those like output issues when you started getting the dints and things? You'd be like, oh, use memory 15 or MW15. Well, that was 15 and 16, but I didn't really tell you that. We don't have that issue. You just create it, you just tell it base, and you move on. So I'm a big fan of that in that aspect of Allen Bradley. You used to have to on the 500 if you were doing RSLogix 500. There's very specific like bits are bit 1 I think or bit 0. Timers are 2. There's a very specific structure, and in your book it did talk about that. And then there for like so 1 to 10 it repeats. It's like okay 1 to 10 is this. It's set in stone, and then after 10 I think you can kind of pick which one is which. But it's the RSLogix 500 is a little bit more particular about what you used. But RSLogix 5000, they've got smart and said, oh, it's just a memory address. We'll just, create a table for you. Don't worry about it. Do it in the background. So, yes. Yep, because this is a base, it's just memory. So just like in Siemens world, memories could be an input, they could be an output. Yep. Aliases are specific to an input or output. So if it's an output, we can use it both. If it's an input, you can't. I know we're getting a little complicated here in the long run. You guys we'll start figuring this out when we start programming things. All right, so the last thing that we need to cover is how do we download this to our PLC. All right, so we're going to have to give it a path. Now, all of you guys aren't plugged into Ethernet. You are on Wi-Fi to HTC network, which means you all have an empty Ethernet port on your computers. I, however, so you guys will just go ahead when we get there. Let's plug it in on of course. You guys will just plug into the back when we get there, and everything will be all on keyboard. All right. However, this process can get a little finicky. All right. This is nowhere near as streamlined as the Siemens one, in my official opinion. All right. So we have to find this PLC on the network. Now, if you've never connected your PLC, your Allen Bradley PLC, to the network yet, all right, you're boned if all you have is an Ethernet cable. All right. But you can't just plug it in like this and program it like the Siemens. Remember how we deleted everything? All it had was a MAC address. You guys deleted the IP address. All it had was a MAC. And the Siemens software was still able to find it on the network. Allen Bradley will not do that. If this does not have an IP address, it will not find it. All right. Now, we do have a little chart up here. I hope this is still accurate. All right. So this is telling you that the computers that you guys are using should have IP addresses on the Ethernet ports of 192.168.152 and then 50 to 69. And I believe it's 51, 52, whatever computer number you have. So if you look at your computer tower that you are using, there is a number. All right, so that should be 50 and then that number. So there should be 7 computers in here, 2, 4, 6, 7. All right, so you guys are actually using 3 because they took 1 to program and 2 didn't work, so I had to bring computer 3 over here. All right, but you guys are on 5 and you guys are on 6. All right, so you should be 50, 3, 5, and 6. All right. And the laptops are 30 to 49. The PLCs are 20 to 29 based on the number on the back of the PLC. So if you look at the back of your PLC, there should be a number written on Sharpie back there. So I should have 36 for me. All right. Keyword there is should be. All right. I make no guarantees because I'm not always the last person to use these things. So hopefully our numbering system is actually accurate. Now I do need to go ahead and add an IP address to my computer. So let me go ahead and up networking. And again, you guys shouldn't have to do this, but why don't you guys walk through this with me just to make sure that we are actually there. All right. Ethernet 2. So if we, I think you guys are running Windows 10. If you go ahead and type in networking, and we should have a network status, like Windows, hit the Windows key and then do a search for network. Start button, bottom left-hand corner if you're a little lost. All right. There's a few different ways. You guys aren't running. Might be running 7. Oh, that's wonderful. Oh, yeah. Okay. We can go that way. So control panel. All right, should bring up something like this. All right, then you want to look, if you're in big tile view, go ahead and click on network and internet. If you are on small icon view, still click on, I believe it's network and internet, network and sharing. And once you get there, we're going to go ahead and do change adapter settings on the left-hand side of that window. And that should bring you up and show you all of your different network interfaces. All right, you guys should have 2. You should have a Wi-Fi and an Ethernet. On the Ethernet one, go ahead, right-click on that and say Properties. Now, there is IP version 4 and IP version 6. All right, we are only worried about IP version 4 for for large companies, IPO version 4 should always be enough. When it comes to the World Wide Web and the big internet, we're actually running out of IP addresses there, so that's why IP version 6 is starting to show up places. But you really shouldn't ever have to use it for personal life. So go ahead and find your Internet Protocol version 4 TCP IPv4, and go ahead and click on Properties. And you all should have numbers already in there. I do not, because I just plugged this Ethernet cord in. So 192.168.152. Yes. And I'm just going to go with 69. All right. So go ahead and type in 192.168.152. 192, period. 168, period. 152, period. And then you should be, what did I say? 50, whatever your computer number is. 56. Okay, 30. You're on the laptop numbers, but that's fine. It's not, hit tab and it should automatically fill it in with 255.255.255.0. Default gateway we can leave blank, and DNS we can leave blank as well. And go ahead and hit OK. Alright, so now that you guys all have IP addresses that are on the same network as our PLCs, hopefully, fingers crossed. At the top of our PLC program, we can go ahead where it says path, and you can see there's a little like Who Active button right to the right of that. Go ahead and click on that. This is actually going to open up a different piece of software. So back in the PLC, yep. Alright. Mine is still thinking, no surprise there. Alright. So, thinking. There we go. Alright. Now, I actually need to, again, change this most likely, but we'll hit the button and see. So, you can see our workstation, and then we've got our gateway for our Ethernet, and then ABEP-1. That's the one we truly want. Alright. Scott, you clicked the wrong button. You clicked the path, hit the button to the right of that one. Alright, and then if you click on ABEP-1 Ethernet, and you have an Ethernet cable plugged into your PLC, which most of you do not. Ethernet cable right there. Do you guys need an Ethernet cable? That doesn't have an end. Probably have to move. Everyone. And it's going to be in the back of the PLC, or the back of the computer you guys are going to have to plug into. Alright. Alright, so hopefully you guys now, and you click that little button. Let me come back into mine now that I've added my driver correctly. You should see your PLC listed. So mine popped up. And you have to click a few more times until you can see the processor. Alright, so hopefully you guys are finding your PLC. Find yours in. Go down the Alright, so if you haven't found it yet, that's okay. I will come around and make sure we get you guys hooked up in a minute, but I just want to continue on with this. So once you get through, you've done your search, you should find your Ethernet port. Then you have to click on backplane, and then you have to click on the one that says processor. So mine's 00 compact logic processor, and I'm gonna hit go online. All right. Now this is actually asking me, do I want to download the code from that's on the PLC right now? But for good measure, I will, just so I can actually see what's going on in this PLC and understand what it's trying to do. All right. So I'm gonna go ahead and hit download. And we can see what's going on. Now, normally you wouldn't want to download what's on there. You'd actually want to upload to it. And under the Go Online button, there was an upload button, so you could do your initial upload there. All right, so now I've gone online. Oh, I guess I did download to it. I didn't get the information from this. That's okay. So you can see I am now online. If I change my preset here to 5000. We can go on. I can toggle outputs. See my output turned on. So, by default, when you're online, you have sunglasses on in Allen Bradley, right? You don't have to go hit the button yourself. It's just like, oh, you're online. You obviously want to see what the hell's going on in the code. So we're just going to show you. Green means power is flowing through that element. No green means it is not. All right. The reason they might not have used Control-T for making a new tag is because that's what they use for toggling bits. So if it's a memory bit, not an input, you can toggle it by just doing a Control-T. You can see how I can flip that output on and off by holding Control-T and toggling the bit start.16, which is kind of nice. In Allen Bradley, you can change some values. So like on the timer here, I can change 5000. Now, it's not happy with me because I don't have... you have to go offline to make most changes, which is one annoying thing here. Or at least one annoying thing to me. Also, you'll notice if you were able to download your code, you would see a path at the top. Alright, it doesn't just say none right now. So it actually has a path listed to your specific PLC. Which I, again, find very, very helpful. Alright, and then let me go ahead and download that again. Download. You'll notice that my timer values are back to 00 though. So if I change it online, it doesn't actually edit the program that's on my computer. So right now I can change this to say 5000. And now when I toggle this, you'll see the timer starts counting. Alright. And you can see how quickly we're screens updating. It's like roughly every 400 milliseconds thereabout. Alright. But again, and that, like, if you remember in Allen Bradley or Siemens World, I couldn't go through and just change this to anything I wanted while the program was running. Alright, so that's kind of nice that you can be like, oh, let me try that timer with this value. Now, that says 9,000 right now. Again, when I go offline, you'll notice that 9,000 goes away. Because I was changing the program actually on the PLC itself. I wasn't changing the program on my computer. Alright, so... very important, because I'll tell you guys, oh, try this, let's increase that. You'll just change it while it's running. And you'll be like, oh, I need to go fix this now because you can see what's wrong. And you'll go fix it, and then you'll come back and be like, why isn't it working? You're like, did you change your timer again? You're like, no, I didn't. Let me go fix that. So, it's a little annoying, all right? Let's go ahead and do a quick kind of overview of the PLCs themselves now. And then we'll get you guys doing some programming. So, on your PLC, let's bring my view up as high as I can. Focus. We're not zoomed in at all. No. Okay. So, up here at the top, we've kind of hit all that up already. All right. However, down here at the bottom, now this is our trainer. All right. Normally, you're not going to see this on a PLC. All right. Because this is not an industrial setup right here. So, on the left, we have our main power button, that bottom left-hand corner. That will kill power to the entire PLC and all the inputs. So, before you guys leave, go ahead and hit that button for me. We have some 24-volt power rails at the side here. Anywhere you see red on the front of this is 24 volts. Anywhere you see blue is 0 volts. Anywhere you see black is an input or output, depending on what section we're in. So, just like to point that out. This next section, let's go ahead and get a little closer now. There we go. So, from here to here, those are all of your inputs. All right. we do have toggle switches on the top, which is kind of nice, so you can just flip switches and see what's happening. All right. But we also have banana jacks at the bottom. All right. So this is how we can plug this into other things. Now you do need to be careful when you're using the banana jacks, because if you have a toggle switch flipped, that will override whatever the sensor you have plugged in is. So if I have a start button plugged in to this last one right here, because I have that toggle switch flipped, it's gonna say true right now, no matter what the hell I do with that button. All right, this will be a flaw that I'll purposely do you guys later when we're doing some troubleshooting. I'll just like flip some switches on you, and it'll just be like, oh, he's true. You're like, why the hell is my sensor not responding? And that's my way of simulating a broken sensor. It's just always being a true signal. Now flip your toggles to the left. Go ahead, flip your toggles to the left. Just, a few. Flip it to the right. Keep going to the right. What do you guys notice? Excellent. To the right is a momentary, so that will spring back when you let go of it. All right, to the left is a latching, so it'll actually hold itself on. I really like that for you guys. It's a nice thing where you can be like, oh, let me just temporarily push this, and when you let go, it flips back. So I do like to point that out. Now, the other thing I want to point out to you guys is when you flip these switches, it's hard to tell. There we go. Little squid. Oh, don't worry about that. All right, when you flip those switches, if you look at the top of your input card, you'll notice that lights turn on. So it tells you which inputs are on right now, or at least what input signals it's seeing it's on. Just like on our Siemens PLCs downstairs, they had a little row of lights. All right, in this case, it's at the top of our input module. Same thing for the outputs will happen. All right. Now, if you look at your PLC, and there are a few of them out there, and you don't see an output light on up here, all right, but you do see down here, right next to the output, that it's on, that means you have burned out outputs. All right, that means a student before you hooked this directly to ground. Yes, you guys have two. This one over here has one. All right. Most likely they hooked an input up to this, and the input triggered and went right to ground and caused the fault on me. All right. So we do need to be careful. Inside these are either MOSFETs or transistors. I don't know which one. Either one, if you put too much current through, is going to burn out. I said both of them work. So both of them will burn out if you put too much power through them. It'd be nice if they had like a built-in resistor in line, so that way you physically couldn't put too much power output of it. But that's not how these decide to work. No. Nope. Not on these. This is an industrial controller. They're assuming you're smart enough not to short out an output. They may or they may not. They could add. Yeah. Yeah, you could put a fuse right off of this, and I still don't know which would blow first, the transistor or the fuse, depending on how high the fuse is and things like that, I really, if you did like a dead short, it could throw 100 amps through that in a moment's notice if you had 100 amps to do it, and that fuse may not blow fast enough to protect that transistor. So a little bit of a give and take going on there. All right. The other thing is, which these I forget what the spec sheet says, but the output cards have only a specific amount of current that they can output at any given point in time, like a max, say maybe 500 milliamps, half an amp. All right. If you have a motor contactor, which for those who haven't seen a motor contactor, this bad boy right here. If you have an older one that has a really big electromagnet in it that takes a lot of current, you can burn out your outputs on your PLCs without actually having wired anything wrong. It's just my motor contactor pulls too much current for me to have that transistor in there supply the power. All right. So because of that, you actually will often go through relays. It seems silly to me to have a PLC control a relay to control a motor contactor. But when you need that much power to flip a motor contactor, it is something you have to do. when I was doing when I was in my undergrad, that was something we had to do. We had 2 different motor contactors on our boards just like this, and one of them we couldn't run directly from the PLC. We had to go through a relay to control it. So if you did like a slow-mo of it, the PLC would turn on, the relay would then start to slowly close and click, and then the motor contactor would start to slowly close and click.
That's like
Traditionally, yeah. Yeah, and there's a lot that's gone on since then. But yeah, I would definitely be looking at your contactors and look at your spec sheet of your PLCs, especially if you're like, I just wired this way. Why the hell did that just blow up? So something to just keep in the back of your mind that this could be a problem. All right, I think most new contactors they have a pretty low current flow. The other thing is if you're running 120 volt contactors versus 24 volt versus 5 volt, depending on the voltage of the contactor, of the coil of the contactor, I should say, the current's going to be changing because this, you still need, half a watt or whatever to pull that contactor down. So at 5 volts, it's going to be, or, if it's a 5 watt contactor, let's go with that. At 5 volts, it's going to be 1 amp. At 25 volts, it's going to be 0.2 of an amp, 0.2 amps. So that is definitely something to kind of keep in the back of your mind. Reasons why we like 24 volts when it comes to our control logic. It's high enough that our current flow can be lower, but it's low enough that we can safely touch it. All right. So you guys do need to be careful with these about short circuiting them out. I don't know what the power supplies in them will do if you do a dead short. Like the Siemens ones, the power supplies just turn off and it's done, and then you unplug it, you plug it back in, and it resets itself. I have no clue what these do, so let's not short circuit these bad boys out. So anyway, that is our input section right there. We have a whole power supply section next, which is positives and grounds, or negatives. Then we have our output section. All right. As I said, they all have their own little light on them, so you should see that, oh, when this light's on, the output is on. All right, or the output is true. Again, if that light is on and up here you don't have a light on, that means you burned out your output, or someone before you burned it out. Only 2 of the PLCs in here have burned out output. Let's keep it that way. All right. And then we have our analog section here, all right? And you'll notice there's a dial right next to a little screen, all right? That dial is selecting which analog input and or output we're actually looking at. So if you look right next to that dial, there's a little text, and it says UI1 to UI4, and then U01 to U02, all right? So depending on where you have that flipped, you'll see the number change. Below that, we have 4 dials to simulate analog inputs. So you can actually, if you set that to UI1 and you turn that first dial, you may see the number on the screen changing because that's the way to simulate an analog input if we didn't have one. If it's not working, flip the little toggle switch right below that up. The toggle switch those toggle switches below it have to be up for the analog input to work. All right. If it's down, the ports below it work. So that's how we would actually wire up an analog input. And then the last section on here, you'll see there's 3 different big plugs and an emergency stop, like little pull-out thing. I have no clue what the emergency stop pull-out thing does. I've tried to figure it out, and I've got no stinking clue. It's not an input that I can see. I don't know if it disables power to certain things. I've got no clue. I've never taken it apart far enough to find out. But those 3 different plugs that you guys see labeled A, B, and C are actually for the water trainers that are right around you guys, the big water tanks. So we can actually unplug the controller that's on them, plug those all the sensors, inputs, and outputs into this, and we can actually control those, which we will be doing later this semester. So another reason why we need to keep all of our PLCs in good operational shape, because if we burn out outputs, if we burn out outputs, that means all of a sudden the pump doesn't work, or this doesn't work, or things like that. So got to be a bit careful there about what inputs and outputs we burn out. So let's just not burn out any, and we have 4 good PLCs still, so that means we're still in good shape. So that is overall my little introduction to Alan Bradley and our trainers.